So we actually have two patterns, one of which you experienced in homework from 2 nights ago, but we're not going to talk about that till Monday. And the other pattern is, again, if you don't catch this idea in trying to find a product, it's okay. The problem comes in is when we factor, it will help you get to an answer faster. So that's what we're going to be talking about. So this is lesson 8.4, and this is the last lesson before taking a quiz. So we'll talk about something on Monday, Tuesday we'll do review, and then Wednesday we'll take our quiz, which will be the last quiz for the quarter because the quarter ends next Friday. Okay. So this particular lesson is about special products. Oh, hello, maybe if I spelled correctly. And, oh boy. And we're going to focus in on squaring a binomial. Because when you square a binomial, there's a pattern that shows up every time, and if you understand the pattern, you can use the pattern to get the answer without having to actually use one of our 3 other strategies. Now, you always can fall back and use one of our 3 strategies. Again, the issue is going to come when we go to the second half of the chapter. Now we undo everything we've just done in the first half of the chapter, and we go back to the binomials, the things in the parentheses. And the one thing that I have neglected to mention is when we are multiplying 2 binomials, and those binomials have exponent as a degree as high as 1, you ended up, so for example, we did x plus 2 times x minus 3, and we get x squared minus x minus 6. What I neglected to mention is now we are in a different type of equation. This is called a quadratic expression. And it's quadratic because of the degree 2. And we're going to we have a whole chapter just on quadratic expressions. That's the one that follows chapter 8. And there's a ton that we can learn because a lot of life forces deal with these quadratic expressions, these quadratic equations. Almost all motion is the result of a quadratic equation. You throw a ball, it takes a particular path where it rises, it comes to a peak point, and it falls down. That shape is called a parabola, and a parabola is the shape you get when you graph a quadratic expression. And we kind of played with that a little bit earlier. So again, we'll have an entire chapter where we're going to work on that kind of idea. So anyway, that's called a quadratic expression. So we've got that down. So I'm going to do a couple problems, and I want to see if you can find the pattern. So we're just going to take 2 binomials that are identical, and we're going to multiply them by themselves. So basically what you're going to see is this. 3x plus 5 squared. Okay. So the first thing we would do is expand it out and write the binomial as many times as the exponent tells us to. And then we would just distribute. So we'd multiply 3x times 3x, and we'd get 9x squared, and 3x times 5, and we'd get 15x. And 5 times 3x, and that's 15x, and we get 5 times 5 is 25. Then we look for like terms, and we get 9x squared plus 30x plus 25. Okay? We get that trinomial. Let's do another one. Let's do with 2 variables. 8c plus 3d. That binomial squared. So again, we start by expanding it, and we get 8c plus 3d times 8c plus 3d. And we distribute, and we get 64c squared. 8c times 3d is 24cd. 3d times 8c. Regardless of the order that we're multiplying, when we write the variables, we write them in the same order. Okay, so CD, CD, and then 3d times 3d we get 9d. And we get 64c squared. We have like terms, so we add them up, and we get 48cd.
Hey, wouldn't it be 9d squared?
Oh, yes, I'm sorry, plus 9d squared. And we get 9d squared. So I want you to take a moment and look at those two original problems. Look at the intermediate, what we got when we squared. Look at the answers, and do you notice any similarities? Do you notice any pattern that's starting to develop? Morgan? Yeah, if you notice, when we did the 3x times the outer 5 and the inner 5 times the inner 3x, we got the same term twice. Okay? Do you notice anything interesting about the numbers on the ends?
They're squared.
Okay? The variables are squared. Are the numbers squared? Yeah. So we've got a perfect square at the beginning. We have a perfect square at the end. Do you notice anything interesting about the signs?
They're all positive.
Okay. They're all positive. Okay. Do you think that would be the case if I changed the binomial from having a plus inside to a minus inside? Do you think they would be all positive, or do you think they'd be all negative, or do you think there'd be a mixture? Okay, so let's do one of those and see what we come up with. So right now, what we've recognized is when we do the math out, we get the same middle term twice. Okay, now, how did we get, let's look at the first one for a second before we try a negative one. So looking here, where does the 15 come from? So a 3 times a 5. Like a 3 times a 5. And what was the middle term in the second one? Okay. Well, not in the answer, but in the intermediate step. What was the middle term we got twice? 24, which is 8 times 3. Okay, keep that in your head. All right, let's try a negative one, all right? Let's do 6p minus 1 quantity squared. So again, we would expand it. Now, first off, you said, most people said mixed. So where is the positive going to be? Where's the negative going to be? What do you guys think? We've got two spots. We've got a middle spot for a sign. We've got the end spot for a sign. So what do you think the middle sign is going to be? Negative? And the end spot? Okay, so that's, let's see if you're right. So we expand 6p minus 1 times 6p minus 1. Let's see, we get 36p squared minus 6p. Negative 1 times 6p is minus 6p. Negative 1 times negative 1 is positive 1. So we look for like terms. We have the same term twice. We add it up. We get negative 12p plus 1. So let's see if what happened when it was a plus in there, similar idea happened. So first off, we'll rewrite on our conjecture about the signs. Did we end up with a negative in the middle and a plus at the end? Okay, why did we end up with a plus at the end? So we're multiplying something by itself. It doesn't matter if he's positive or if he's negative. I'm going to get a positive every time. Okay, so that makes sense. All right, now, looking here and looking at the middle terms we got, what was the coefficient of the middle term? The individual middle terms. Negative 6. Interesting. Is that a perfect square? Is 1 squared equal to 1? Yeah. So basically what we have is a pattern. And the pattern looks like this. And it doesn't matter if you have a sum, meaning there's a plus in between the two terms, or a difference, there's a subtraction between the two terms. What you're going to end up doing is you're going to end up taking the first term and you're going to square it. So 6p squared is 36p squared. And then whatever the sign is, so I'm going to color him out as green, is going to be the sign in the middle. So whatever the sign is in the oh, sorry, forgot the crucial thing here was we're squaring this sucker. So whatever the sign is in that binomial is going to be the sign of your middle term. Now, you guys told me there were 2 of the middle terms. And how we got the 2 middle terms was really by multiplying the 2 terms inside the binomial together. Now, we always have a plus because we're multiplying something by itself. 2 negatives make a positive, 2 positives make a positive. And we square that. So this is the shortcut. Now again, if the shortcut is kind of hard for you to keep track of, you have no issue with expanding out and doing exactly what we did and getting the answer right. But I am going to come back to the shortcut again when we get into the next half of the chapter. Same idea works even if it's a minus sign. We square the first term. The middle term will be negative. So it matches the sign inside the binomial. We're going to get 2 of the product of our 2 terms. And then we're always going to get a plus, and then we're going to square the back term. Let's do an example, one you get to do all by yourself, and let's see how it works. So, directions are going to say, oh, pick up the mess. Find each product. So, if we have 3x plus 4y, that quantity squared, what do you think the answer is? See if you can apply the shortcut, the pattern, to this problem. If you can't, you can always expand it out and multiply it that way. But what I want you to try to do is apply the pattern. So what do we do to the first term? What do we do to get the middle term? What do we do to get the end term? Okay, Brandon, what do you think?
9x plus 12xy plus 16y.
Okay, we had some issues. You got a good start, but we had some issues. Okay? Patrick, are you trying this? Jack, are you trying this? Okay? Remember what the pattern says. First term, square it. If it says plus, we write plus. Second term, we double the product of the 2 terms. Third, we add the last term squared. Savannah.
9x squared plus 24xy plus 16y squared.
That's the answer we're looking for. This is how the pattern works. First term, squared. Plus is because it says plus. Double the product of the 2 terms. And then it's always plus and square the last term. 9x squared plus 24xy equals 6, no, I'm sorry, not equals, plus 16y squared. So, if you understand this pattern, the answer comes like that. Okay? So, let's try another one. Yes?
Why would it be 12xy?
Because we have 2 of them.
Or would it be 12xy squared?
No. 2 means not to square it, but to double it. We double it. Let's do, see, what problems do I have you do? Let's do 4c minus 7d. That's squared. It's like, dude, I hardly finished writing it. Okay, I like that. Okay, Jack, I don't see you working. Okay, Jackie, what do you think?
16c squared minus 56cd plus 49 squared.
Bingo! So again, what you're doing is taking 4c and squaring it. It says minus in the binomial, so our middle is minus. We're going to double the product of the 2 terms. And then it's always going to be positive, and we're going to square the last term. So that gives us 16c squared minus 56cd plus 49d squared. And that's the answer. So that's what you guys are working on tonight. Again, if the pattern's not making sense, you have a fallback plan, but I'd like you to try to work on the pattern because the pattern's going to be crucial when we get to the next half of the chapter. Okay, that's it.